Partial fraction decomposition. Write the following fractions as a sum of simpler fractions. So we got two complex fractions. Now we are writing them as a sum of two fractions because we got two factors on the bottom in each of these questions. Okay. So here the bottom is already factored. So we got s and s squared plus 4. So we can write this as just s and the second factor plus 4. It's a linear degree 1, so we just have a constant. So s square means degree 2, so we need degree 1 on the top. A is used, so it's like degree 1 means as plus b, but a is already used, so we're going to write b and c. Okay, so we let this fraction as a sum of two simpler fractions. Now we need to determine the values of a, b and c. First, we multiply through by the common denominator, okay, which is this. Then this implies 8 equals, these are two distinct factors, so a times this plus this times this. So a times s squared plus 4 plus this one times s, or s times this one, doesn't matter, same thing. Okay, now we can, this is true for any value of s, so we can take some values so that we can isolate a, b and c. One of many ways, maybe a couple of ways, is let's combine these and go from there. So this is 8 in the left side, here is distribute a, so we get as squared plus 4a plus distribute this as squared plus cs. Let's combine the like terms in the right side, as squared plus bs squared. We can factor s squared out, so a plus b. That's the s squared, then there is cs, and then constant is 4a. Okay, in the left side we got only 8, okay, which is constant as a cs, so we can always add 0 times s and 0 times s squared. So I'm adding 2 just to match. That means a plus b must be equal to 0 because there is no s squared term in the left side, and c must be 0, and 4a is 8. Okay, so this implies a plus b, I don't have to even write this one because s squared, there is no s squared term in the left, so this coefficient must be 0. There is no term containing s, so c is 0, and 4a is 8, it's the constant. Let's solve. So c is 0, 4a equals 8 means a is 2. Okay, divide by 4, and c is 0. If we plug this a equals 2 in here, 2 plus b equals 0, that means b is, subtract 2, b is negative 2. So a is 2, b is negative 2, and c is 0. So this is just equating the coefficients from both sides. So after we have this, so this s, we could have taken s equals 0. Then on the both sides, so this would be 0. So this would be 4a equals 8. Then a would be 2. But then we have to do something like this anyway. So it's sometimes it's better to go through this way. Okay. So let me get the eraser here. So thus, let me write over here. After this one, this fraction 8 over equals a over s. A is 2 plus bs. C is 0, so negative 2s over s squared plus 4. Now we can take the inverse Laplace. Okay. Now the next problem is here. This one, so we let this being, so we got two quadratic factors on the bottom, and this does not factor. Okay, it's a degree 2, so by rule we have to write degree 1 on the top, which is as plus b, and same thing here. But if we look at closely here, we don't have any terms containing s on the top, only number and this one. So for this Laplace transform, we don't need this one, only a constant would work. Okay, it only works when we are trying to find inverse Laplace transform. Okay, there are no s terms, so all we can do is just write a constant, Even if we write as plus b, that a is gonna be 0, so we'll have just a constant anyways. So we'll let this one, that means this 4 equals, these are distinct factors, so a times this plus b times this. Let's equate the coefficients like the previous. As squared plus 9a, same thing, bs squared plus b. So I'm going to combine first term, so a plus b, and 9a is constant, b is called constant, so 9a plus b. So in the left side we got only 4, which is constant, so we can, but we have something s squared in the right side, so we can always write 0 times s squared. That means these two coefficients must match, so a plus b is 0 and 9a plus b is 4. Okay, so this implies a plus b 0 and 9a plus b equals 4. Let's solve for a and b. Okay. A plus b 0 means what? We can write, or these two fractions we can subtract. Okay, we can subtract because I see b. So to solve this system of linear equations, we have several methods. Method of substitution, elimination. I'm just trying to eliminate. Subtract second equation from the first. If we subtract, we just change the sign of the bottom. Okay, so b and b cancel. And then what we left with? A minus 9a minus 8a equals 0 minus 4 minus 4. Now it's a negative 8 times a. Divide by negative 8. So a is negative 4 divided by negative 8. So 1/2. Or we could have solved for a plus b equals 0. That means b equals negative a. And replace b by negative a. So we end up getting the same thing. Okay. And then now a is 1/2 means 1/2 plus b equals 0. Because we got a plus b 0. So b is negative 1/2. Okay. So we can go here and then write down the final answer. Thus, this fraction 4 over equals a over that. A is 1/2. 1/2 over plus b. Then now we can take inverse Laplace transform.